Let's move on to verification validation. As I've talked about before, verification looks at whether we have solved our mathematical model correctly. So we need to check if we have input the right mathematical model into the tool. And so we will check if our results are consistent with the mathematical model. That is, the results that we have here are consistent with the mathematical model that we want to solve. And we'll check the level of numerical errors. So that's the second verification check. And we know that the big errors are the discretization errors and the linearization errors. And the third check is, under verification, is checking if our hand calcs match with the results in the fully developed region. Because if we solve the mathematical model right, then it should give us a result that matches the analytical result that we saw in pre-analysis. So we'll do the verification. Validation involves looking at whether that mathematical model is a correct representation of the physics, and in this case we don't have experimental data, so we won't, in this particular module we won't be doing validation, and we'll be doing verification.